Hi everyone, this is teacher Justina and welcome back to my channel. And then if you are new, then do not forget to subscribe, like, and share. And also do not forget to hit the notification bell for more updates. And also you can please leave your comments below and you can also suggest topic for discussion. Our video for today is all about the distance formula. And this is for grade 11 STEM for the pre-calculus subject. Okay, so let us explore. Okay, how do you find the distance between 2 points? Okay, so the distance between 2 points is the absolute value of the difference of their coordinates. Okay, so you are given a segment xy and the 2 points there are point x and y, and how do we look for the distance between 2 points? And remember, the 2 points are vertically drawn. And then the next one, what if we are to look for the distance this for this segment RS and the points from R to S, which is horizontally drawn? And then for this also, what will happen if we will be looking for the distances between all the segments which is slantingly drawn? Okay, so let us proceed. What is the distance from point A to point B and then also point C? Okay, point C to point D. So if x sub 1 and x sub 2 are the coordinates of A and B respectively, so as you have seen, we have the x sub 1 and the y sub 1 because A as our first point. So there we can have the first x inside first y, x sub 1 and y sub 1, and B as our second point. So there is our x sub 2 and y sub 2. Okay, but remember that AB or point A to B, these 2 points are horizontally drawn. So what shall we do in getting the distance from A to B? We just simply, okay, it is being mentioned in here that if x sub 1 and x sub 2 are coordinates of A and B respectively on a horizontal number line, then the distance between A and B is denoted by this formula. So the distance from A to B is equal to the difference. So when we see the difference, so it's minus the difference between their coordinates. So what coordinates? So their x's, because we have uh, the 2 points A and B parallel to the y-axis. So meaning we will be getting the difference of their x's or the x coordinates. So therefore, as the formula goes, that from A to B is equal to the absolute value. Uh, our x sub 2 is 3, okay, minus, okay, so that is minus. Our x sub 1 is negative 4, okay, and then to further simplify, the distance from A to B is equal to uh, the absolute value of 3 and then negative times negative 4, we have a positive 4. So therefore the absolute value of the distance from A to B is equal to the absolute value of 7. So as we have known, the absolute value of any number is always a positive, and that is all about a distance. There's no such distance negative, so therefore the absolute value is 7. That is from A to B, it's 7. While the C to D, okay, while the C to D is described by still x sub 2 minus x sub 1, and from C to D our x's are 6 minus our first x is negative 2, that is y. To further simplify, 6 plus 2 because that is coming from negative, okay, negative times negative, that is why we have 6 plus 2, and CD or from the point C to D is equal to the absolute value of 8, and for that the distance from C to D is equal to 8. Okay, so the distance between 2 points or length of a segment is always a unique positive real number. So again, the distance between any 2 points is always a positive real number. That is why it is necessary to use the symbol absolute value for further reference. Okay, so this time we will be finding the distance between 2 points in which it is or they are vertically drawn. Okay, if y sub 1 and y sub 2 are the coordinates of E and F, okay, and then on a vertical number line, then the distance between E to F is denoted by the formula. Okay, so simply we are going to subtract their y coordinates. Why we're subtracting their y coordinates, not the x's? Because this is no longer horizontally drawn, it is already vertically drawn, meaning we will be focusing on the on getting the difference of their y's or the y coordinates. Okay, so therefore from E to F we will be having the y sub 2, which is negative 4, okay, minus, okay, that is y sub 2, and then minus our y sub 1 is 3. So therefore that will be the distance from E to F is equal to the absolute value of negative 7. And remember that the absolute value of any number is always a positive real number because there's no such negative distance. So the distance from E to F is 7. And while the while the G to H is y sub 2 minus y sub 1. So therefore we have y sub 2 which is negative 3, and then minus our y sub 1 is 1, and so far it is absolute value of negative 4, and the absolute value of negative 4 is positive 4. So the distance from G to H is equal to 4 units. Okay, let's proceed to this next. Okay, so far uh, this points A to N, they are vertically drawn, and M to N is also horizontally drawn. So what will happen to that? As you have seen, this is already a right triangle. So when we say right triangle, we have to recall the Pythagorean theorem as to find out the value of this side C. Why we are to concentrating on the distance from M to A. This is slantingly drawn and this is different to A to N and M to N. Okay, so for A or for side A, we simply recall the difference between their y coordinates because this side A is vertically drawn. So y sub 2 minus y sub 1, while this M to N or points M uh, to point N, remember that this is horizontally drawn, thus we will be subtracting their excess. Okay, and that's it. Our side B, because this is side B is said to be subtracting their excess. So x sub 2 minus x sub 1. So what we are trying to find out is the distance from A to M, which is already slantingly drawn. Okay, for that, we need to recall the Pythagoras theorem or the so-called Pythagorean theorem. And what was the theorem all about? It says that the square of the hypotenuse, this one, this is the longest side of a right triangle. So the longest side of a right triangle is said to be the hypotenuse. And this is the side B or the base of a right triangle, and this one is said to be the altitude. Okay, so it says that the square of the hypotenuse c squared is equal to the sum of the squares of the two legs. So where are the two legs? The two legs are the A and the B, meaning we will be adding the squares of A and B, and that will be our C squared. So how do we look for the distance from M to A? Okay, so we are now ready for substitution. The C there is to be found. Thus, we just rewrite it. And so for our A, that's 1, our side A is said to be y sub 2 minus y sub 1. Okay, again, our side A is represented by y sub 2 minus y sub 1. And then the formula says that we are to square the A side and then plus. Okay, what is our B? Our B is said to be x sub 2 minus x sub 1, and then there is a square there in the formula, and this is already the representation according to this given right triangle with their corresponding uh, sides. Okay, so, or it could be written into like this. Why we are extracting the square root both sides? Remember that we are getting the value of c, and then the c has a square. So therefore, to isolate the square there, we need to extract the square root both sides. Okay, so far I am just interchanging the x and the y. Okay, so anyway, they are just the same because we are on addition, and addition is commutative. So therefore, for that, we were able to isolate this. We're able to isolate already the radical sign because the index there is 2 and the exponent of c is 2. Therefore, we have already the c. And that c is the line or the points M to A. And so therefore, what is this now? What formula is this? And this is said to be the distance formula. And the distance formula says that any point, and that P to Q is referring to any point, it is always equal to the square root of the square, the square of the difference of the x coordinates plus the square of the difference of the y coordinates. Okay, so let us now find the distance of this following segments. Okay, so from O to P, from points O to P, okay, we have already the distance formula. So we have the x sub 2, meaning when we say O to P, we have O as our x sub 1 and y sub 1, and our x sub 2 and then the y sub 2. Again, O is the first point being mentioned, and these are the x's, the x sub 1 and y sub 1. This is our x sub 2 and this is our y sub 2. So therefore, our x sub 2 is 3, this one, and minus negative 4. Okay, and then plus, okay, square. The y sub 2 is 3, this one, minus our y sub 1 is negative 2. So that's it. So further simplify, we have 3. Okay, and the negative times negative, we have a positive 4, and 3 plus 4 is already a 7. And then 3 negative times negative 2, we have a positive 2, and 3 plus 2 will gives us a 5. So 7 squared plus 5 squared is equal to 49. This is 49 plus 25. Okay, and that will gives us 74. And then what is the square root of 74 in two decimal places? I'm sorry, in its one decimal place. Okay, so OP is approximately 8.6 units. And let's proceed to the next, which is the XY. So the X is considering the first point. Well, anyway, you can interchange as to if you will be having the Y as your first point and then followed by X as your second point. Question, are we getting the same distance? Yes, we are still getting the same distance. Even we can interchange the 2 points. So X sub 2 is 3 and then minus negative 5 is our x sub 1, and then plus our y sub 2 is okay, 0, and then minus negative 4, And so for to further simplify, that will be 3 and then negative and negative, positive 5. So 8 squared, and this will be 4 squared. So therefore 64 plus 16, the 8 there is 64 plus 16 will gives us 80, and the square root of 80 is 8.9 approximately. And the last there is the mn. So the mn, the x of 2 there is 5 minus negative 5. Okay, again, this is x of 1, this is our x of 2, y sub 2, and this is our y sub 1. So therefore, that will be 10 squared plus negative c squared, so that will be 136, and approximately m to n is equal to 11.7 units. Okay, so let us have this problem. The endpoints of the base of an isosceles triangle are being described by the points A, 1, 2, and point B, 4, negative 1. Find the y-coordinate of the third vertex if its x-coordinate is 6. Okay, we are going to find the coordinates of point C in which x is 6. But this time, we need to recall the isosceles triangle. What is an isosceles triangle? So an isosceles triangle is a triangle with two sides are congruent. So when we say two sides are congruent, we will be expecting that their measures are equal. And the third side is said to be the base. Okay, and then so far the points A and B are already plotted on the Cartesian plane. So where can we possibly locate point C? Would it be in this particular area or particular location? Would it be on 6 and positive 1, or on this point in which the y coordinate is 3? Okay, so but guessing in that way is not that accurate. But what we are trying to find this time is letting the coordinate of point C to be 6, and the y coordinate will be remaining it as y. Okay? And since triangle ABC is isosceles, then AB is the base as you have seen. Okay? And then side AC is equal to side BC. And then for this, since AC is equal to BC, then let us have the distance formula. So from point A to any of the possible location of point C, we'll be having the 6 minus 1 squared plus y minus 2 squared. So meaning this is our x of 2, this is our x of 1, that is why 6 minus 1, and our y sub 2, and this is our y sub 1. So our y sub 2 is y, and our y sub 1 is 2. And at the same time, BC, okay, so B to C, our x sub 2 is 6, and our x sub 1 is 4. So we have 6 minus 4 quantities to the power of 2, and our y sub 2 and our y sub 1. Our y sub 2 is y, while our y sub 1 is negative 1. So y minus negative 1 squared. Okay, but AC, meaning the side AC is equal to side BC. So therefore, to solve for the value of y, we need to equate the values of A to C and B to C. So therefore, we have to do it this way. Okay, so referring this statement or this expression from the upper expression, so we have equated already. So since this is side AC and this is side BC, and then for this time, we need to simplify 6 minus 1, and that is 5. So 5 squared, and then plus y minus 2. Quantity square is equal to the side BC. So 6 minus 4 is 2. And then we have to remain it y plus 1, because negative times negative, we have a plus or a positive. So therefore, y plus 1 quantity square. Okay, and since we have to recall that this is already a square of a binomial. Okay, so when we say square of a binomial, we have to expand them, and then expanding them will be uh, resulting to a perfect square trinomial. So the 5 square is uh, being to be simplified into 25, and then y minus 2 quantity square will be resulting to y squared minus 4 plus 4. In the 2 square there is a 4, and then expanding the y plus 1 will gives us y squared plus 2y plus 1. And why we were able to extracting the square root both sides, because what we try to isolate this time is the radical sign. So the radical sign uh, will be isolated by squaring both sides. So when we say squaring both sides, we have to do it this way. So squaring both sides, letting us to isolate the radical sign. So it will be already the terms uh, the terms left are 25 plus y squared minus 4y plus 4. And then on the right side, or the BC, we have already a 4 plus the expanded form of y plus 1 to the power of 2. Okay, and then the next is we need to combine similar terms. We have the y squared here, and then uh, transposing the y squared, so we have a negative y squared. The negative 4y will be rewritten, and then the 2y, the positive 2y will be transposed. It will become negative 2y. And then the 25 and the 4 will be transposed. So we have the negative 25 and the negative 4. Remain the sign of 4 and 1. Thus, this will be cancelled already. The negative 4y and negative 2y will give us negative 6y, which is equal to negative 24, because the simplified form of this is already negative 24. And for that, we will be getting the value of y, then we will be dividing both sides by negative 6. And for that, y is equal to 4. And in this manner, we were able to get already the y coordinate of the point C, which is already 4. So the third vertex coordinates are 6 and 4. So what would be its graph? Okay, so as you have seen, the point A, which is 1, 2, in the point B, which is 4, negative 1. So since it is already 6, 4 as our point C coordinates, so therefore, as you have seen, it is very evident that AC is really equal to BC. Okay, let us have this second problem. A point A, which is x comma 1, is the square root of 29 units from B, which is 83. So find x. So this time, as you have seen, a point A, it is being mentioned in here that a point A is being described by the coordinates x1, and then the point B is 83. Meaning, we need to find out the coordinate of point A, the x coordinate of our point A, because if we can find the coordinates of x in point A, we have already the distance from A to B rather, which is square root of 29. So therefore, what shall we do? We are going to have it this way, the distance formula. And since AB is already, the length of AB is already known, which is square root of 29. So therefore, we were able to simplify, not simplify, but substituting the x of 2. Our x of 2 is 8, and our x sub 1 is x. So remain it as x, plus our y sub 2 is 3, while our y sub 1 is 1, which is already equal to the square root of 29. So this time, we will no longer write the distance from A to B or the AB itself, because it is already known, which is square root of 29. So therefore, uh, we're able to uh, simplify the 8 minus x to the power of 2. Again, this is a square of a binomial in which its expanded form is square of 8 is 64 minus twice of 8 in x. So 8x times 2 will gives us 16x. Whatever the sign, there will be followed. And then squaring the last term, which is x squared. And then plus 2 squared. Where did we get the 2 squared? 3 minus 1, which is 2. So square 2, which is 2 square. So therefore, what shall we do next? We will be getting the value of our x. So we are going to isolate the radical sign by squaring both sides. So squaring them. Okay, that's it. Okay, so therefore, the remaining terms are 29 is equal to 64 minus 16x plus x squared plus 4. So we simply isolate the radical sign. And for this, we will be combining similar terms. Okay, the 64 minus 16x plus x squared plus 4 is equal to 29. We are just interchanging their position. Okay, and then for that, we will be getting the value of x. So what is the next step? Is we were able to combine all similar terms. So we have the x squared as our first term because we will be writing them into decreasing order. So the highest exponent will be our leading term minus 16x, and then positive 64 plus 4, and the 29 will be transposed. Thus, it will gives us x squared minus 16x plus 39 is equal to 0. We are not yet done getting the value of x. Okay, so for this, I'm sure you remember as to how to factor out this kind of trinomial. So what are the factors of 39 that will gives us possibly a sum of negative 16? So factors of positive 39 that will gives us a negative 16 are x minus 13 and x minus 3 because negative 13 times negative 3 will gives us positive 39. If we will be adding negative 13 and negative 3, we'll be having a negative 16 as a result. So for this, we were able to have two values of x. Why we have two values of x? Because this is already a quadratic equation. So quadratic equation have two or has two values of x. So therefore, the first x is 13 coming from this, and the second value of x is positive 3 coming from this factor. So therefore, what are the possible coordinates of our point A? It could be 13 and 1 because it is in here. So another possible is 3 and 1. So from this, again 13 and 1 coming from this first value. It could be also 3 and 1 coming from this value. So let us try graph. Okay. So let us plot the 8, 3. That one. This is 8 and this is 3. So plotting point B. And the possible location of our A, which is 3, 1. This is 3 and this is 1. And that's it, 3, 1. And then another possibility there is plotting the 13, 1. So the 13, 1 is in here. So this is 13. Okay, and 13, 1. That's it. So if we will be connecting A to B, and then what about if we will be having the A to B, that's 1. So A to B is square root of 29 units, and also A to B from 13, 1 to 8, 3 will be also square root of 29 units. Okay, guys, I hope you've learned something from my video today. This is quite tedious, but I hope you were able to recall some of the concepts or some of the basic skills in solving geometric problems. Guys, I hope you will never forget to subscribe if you are not yet done subscribing. And please do like, share, and leave your comment below. And then also you can also suggest topic if you want. This has been Teacher Justina, and thank you for watching, and see you on my next videos. Goodbye everyone, that in all things God may be glorified.